Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Resonance stabilization energy, delocalization energy, of benzene is measured by comparing the actual heat of hydrogenation of benzene with the hypothetical heat of hydrogenation of 1,3,5-cyclohexatriene, a calculus structure with 3 isolated double bonds. Moving on to the next step. Establish the reference point. Cyclohexene, 1 double bond, has a heat of hydrogenation of approximately -120 kJ/mol. A hypothetical 1,3,5-cyclohexatriene with 3 isolated, non-interacting, double bonds would be expected to release 3 times 120 equals 360 kJ/mol upon complete hydrogenation to cyclohexane. Moving on to the next step. Actual measurement. The actual heat of hydrogenation of benzene is approximately -208 kJ/mol. It releases only 208 kJ/mol. And for the final step, calculate the difference. The hypothetical 1,3,5-cyclohexatriene would give off 360 kJ/mol, but benzene actually gives off only 208 kJ/mol. The difference is 360 minus 208 equals 152 kJ/mol. Interpret the result. Because benzene is more stable than the hypothetical 1,3,5-cyclohexatriene by 152 kJ/mol, due to aromatic delocalization, benzene releases 152 kJ/mol less heat than the hypothetical cyclohexatriene would. In other words, benzene gives off 152 kJ/mol less heat than the cyclohexatriene. Why other options fail? A. Benzene does not absorb heat. Hydrogenation is exothermic for both. B. Benzene gives off less heat, not more, because it is more stable. C. Benzene does not absorb heat relative to cyclohexatriene, it simply releases less heat. Therefore, the correct answer is D. Therefore, the correct answer is option D.